You can see this chart of body mass index, which is a well-known measure for health and overweight and obesity. Say for example, my height is somewhere around 5'4" and my weight is somewhere around this 80. So I come under the category of obese and my target should be going down to healthy, which can be around 65.9 kgs. So you can see here these values on the chart in yellow, green, blue, orange and red color are the body mass index. We have the weights on the horizontal side and the heights on the vertical side. So this is a very well-known measure called as body mass index. This is one of the type of scores, Similarly, we have other scores also. Like here what we are seeing is body mass index, and you can see the legends here. Color legends are there for underweight, normal, overweight, pre-obese and obese. Same thing I'll check. My height is somewhere around here 165 centimeters and my weight is somewhere around here 80. So my body mass index is coming to be around 29.4, and this legend says that I am pre-obese or obese, on the verge of getting obese, so I need to take care of my health. So this is one of the scores called as body mass index, and the formula for body mass index is mass divided by height square. There is one more measure known as page rank, and we know that Google has given us this page ranking algorithm, and page rank basically indicates the importance of a page on a website, and that is determined by how many outcoming links are reaching out to this page. And we'll directly look at the example of how Google calculates the page ranks. Say for example, this is our internet, and this internet can be represented in the form of a graph, right? So this graph has nodes A, B, C, D, and it has few outgoing and incoming edges. Say for example, A node is there. It has one incoming edge from C and two outgoing edges to B and C, like that. So initially, the page rank is equal 1 divided by number of nodes, and the number of nodes are 4. So 1 divided by 4, that becomes 1 by 4. In the first iteration, the page rank of all the nodes, and nodes here represent the pages on websites which are having hyperlinks. So these are the 4 pages A, B, C, D, and they have in the first iteration the page rank as 1 by 4 equally. Now we need to calculate the page rank for individual nodes. Let us say we want to calculate the page rank for A. The page rank for A is dependent on the incoming edge node. So what is the incoming edge to A? The incoming edge to A is this, which is coming from C. So the page rank of A is dependent on the page rank of C, and how many outgoing links are there with C. So how many outgoing links are there with C? 1, 2 and 3. So 3 outgoing links. So what is page rank of C? Page rank of C is 1 by 4. So 1 by 4 divided by 3, that will be the page rank of A. Similarly, we have to calculate the page rank of B, C and D. Say for example, page rank of B is dependent on the number of incoming edges. So B, to B, edge from A is coming and edge from C is coming. So the page rank of B is dependent on page rank of A plus page rank of C. So that's how we'll be calculating this. So like that, we'll be calculating for C and D as well, and we can put that in the chart in the second iteration, as page rank of B is coming to be 5 by 24, C is coming to be 3 by 8, D is coming to be 4 by 12, and this goes on. So this is how page ranking algorithm works, which is given to us by Google, which indicates the importance of a page on a website. So there is one more well-known score. We are speaking about basically scores here. One score was the body mass index well-known score. One score is the page ranking score, and one score we are mentioning now here is the Z score. And we know that this formula for Z score is x minus mu upon sigma, where mu indicates the mean and sigma indicates the standard deviation, x indicates the raw score. So what this z-score will be doing is it will be bringing the arbitrary variables to a uniform range. So bringing uniformity, bringing normality, normalization is the objective of a z-score. So if I take the average value of z-score for all the points, it comes to 0. It comes to 0. Let us take one example to understand the importance of z-score. Say for example, the GRE test score is 1100 obtained by some student, and the mean score for that GRE is 1026, and the standard deviation score is 209. So as per the formula, what is the formula for z-score? X minus mu by sigma, where mu is the mean and sigma is the standard deviation. So we have the values of all the three. So we'll be putting the values of all those three, and we'll be getting a value called as 0.345. Once we get this 0.345, what I'll be doing is I'll be using the first digit 0.3 and the second digit this to get this row and get a particular column, and I can see the last digit as 0.5, and if I take this, the value is coming to be 0.6368. This is actually a z-score table. Now this 0.6368 is multiplied by 100, so which is coming to be 63.68. Okay, so what it indicates? It indicates that 63.68% of people or students who have taken GRE test have scored less than the given raw score. And what is the raw score? 1100. So the raw score is 1100, and this percentage of people, 63.68% of people who have written the GRE are having the less score. Now we have discussed, first is the body mass index with the formula mass upon height square. Second, the page rank. Third, the z-score normalization. Why we are discussing this? We are discussing this because in unit 3 of our subject data science, fundamentals of data science, we are discussing about scores and rankings. We are discussing about scores and rankings, how to develop those scores, what is z-score, what is normalization, and further discussion is there. So our focus today will be on the initial basics of scores and rankings, how to develop score system, and so on. And for this, we'll be referring a textbook by Skinner, and the name of the book is Data Science Design Manual, and the page numbers being mentioned here for the discussion start from 95. So let us go to this. Okay, now let us look at this. What is the title of the chapter? Scores and Rankings. The title of the chapter is Scores and Rankings, and here a very good how do I put it, quote by Mark Cuban is there, which says that money is a scoreboard where you can rank how you are doing against other people, right? Successful, how you are, I am successful than others, how it is rated depending on how much money you have, right? So that can be one of the scoring systems. But what exactly are scoring functions? So you may be having multi-dimensional records about a single value. So you will be converting those multi-dimensional records to a single value, and that will be highlighting some property of the data. Once you get the score, then you can sort them, and you call them as sorted or ranked, right? And the most common example of these kind of scores and ranks are student grades, right? We teach our students different subjects, and we assess our students through internal exams, assignments, projects. So there are direct and indirect ways of assessing the students. Then we will be allocating the grades to the students. So that grade is calculated by getting their scores, is it not? So different teachers may be using different grading rubrics, right? So some properties or characteristics of these grading rubrics are, there is a degree of arbitrariness. What is the meaning of this? So different teachers are using different kinds of scores, and they are sure about their way of assessment, their way of scores, their way of ranks. There is lack of validation data, as in there is no such golden standard for saying that this is the correct way of scores and ranks and grading, right? But still, they have a property of general robustness, because most of the grading system, if you compare them, they'll be producing the similar results. So basically this unit 3 deals with discussion on scores and rankings. So let us quickly move on to the first one, the body mass index. Okay. Basically body mass index, we have just seen that it is used to check the obesity, it is used to check am I overweight or not, and this is the formula for that. BMI is equal to mass upon height square. We have taken the example for that here. Is it not? If you look at this chart, you can see this is a BMI chart for 1,000 American people, and the legends are in red color, green color, and blue color, indicating normal, overweight, and obese. And this plot is called as a scatter plot, and each dot indicates each individual. So there may be how many dots on this graph? On this graph, there may be 1,000 dots, because here it is mentioned in the label that there are 1,000 American representatives. What I can see here, there are a few outliers also. For example, here there is an outlier who is crossing 200 kilogram of weight. Here there is an outlier who has crossed 200 kilograms of weight. So you can see this blue color one which indicates the obese people, and the red color one indicates the normal people. The heights and weights combination of the body mass indicates the normal people. Is it not? If you look at say the same BMI distribution, if you look for athletes and players, say football players or basketball players, so usually what we find is basketball players are very tall, and football players are very heavy, right? So you can see here their distributions are also pretty similar to the typical BMI indexes which we are seeing here in the scatter plots here. But one more very interesting observation is here in this graph, where the athletes or the sportsmen will be placed on the ground depending on their weight also. If you look at this center, this blue color legend, forwards red color, and guards green color, and I know what are these legends color indicates. Obese are blue colored one, normal are the red color one, and overweight are the green color one. Accordingly, their placements on the fields are also determined. Now, how do I develop a scoring system? I have seen various scores, like which scores I have seen? I have seen a BMI, I have seen a Z score, I have seen a page rank. There can be many more also, like ELO ranking for chess. But how do I develop a scoring system? As such, there is no golden standard for developing a scoring system. Okay. But what we can do, we can improve a grading system or improve a scoring system with the help of proxies, which will be giving as good as a gold standard kind of results. There are different examples. Say, for example, if I decide that a particular celebrity is very famous, how do I determine that that can be the count of the autographs? So, suppose I say a player is a good player among top players. So, how do I decide that? Maybe for that there may be different inputs through numbers, is it not? So you have something called as scores and you have something called as rankings. So first you'll be determining the scores, then you'll be determining the ranking by just sorting the scores, and we'll be saying among top 5, among top 10, top 20, like that, is it not? So usually these top 20s and top 100s will be calculated depending on the votes of the judges, votes of the experts. Even for university academic ranking, for example, we see an article. In that article, it is mentioned that the top 50 universities in India or top 10 universities in USA. How that may be determined? That may be dependent on many aspects like faculty-student ratio, acceptance ratio, test scores of the students, maybe sports support, maybe the placements, maybe many more aspects. Similarly, you have page rank, which we have just mentioned. You have class rank also. Suppose he is the top ranker. How do I determine a student is a ranker in the class? Depending on his scores and ranks, right? First, we'll be determining the scores. After determining the scores, we'll be sorting them and we'll be getting the ranks like that. So it means what scores and ranking are interdependent. So I can derive one from the another one. Is it not? Okay, which scoring function is a good scoring function? So that can be easily said that if it is easily computable, that's a good scoring function. Say for example, BMI is a very simple example where you are calculating mass and height square using simple algebra, or it is easily understandable. The interpretation of the variable is monotonic. The features correlated with the objectives, is it not? And they'll be producing generally satisfying results even on outliers also. They use normalized variables, maybe they'll be using z-scores. So this is a small discussion on the topic scores and rankings, developing how to develop good scores, what is z-score, kind of. So we started this discussion for the subject, fundamentals of data science, using the book Data Science Design Manual by Stevens K. Sima. Thank you.